now going to look at the concept of factoring. Factoring is taking multiplication in reverse. And we're looking for things that are shared through numbers or quantities, being if they're a variable quantity or not. So we can take the numbers 9 and 12. And 12. And we can break them into factors. And these will be common numbers that multiply into them. And the standard way is to realize 3 and 3 multiply into 9. Now what I do when I'm not sure what a factor is of a number is I'll plug it into my calculator. I'll go 9. I'll divide by 8. I get a decimal. So that is not a factor. 9 divided by 7. I get a decimal. It's not a factor. And I continue all the way down until I get to 3. And 3 gives me 3. And I'll write these two numbers as my factors. We will see that we get patterns in factors. So let me say it's a 9. Plug into my calculator. 9 divided by 8 has a decimal. So I get 3 and 3. Now 3 and 3 aren't divisible by anything but 1. They're prime. And we call these the prime factors of 9. So 9 can be written in terms of its prime factors. So 9 in prime factors is 3 times 3. Well, if we do the same thing with 12, again, I'm plugging 12 into my calculator. 12 divided by 11 gives me a decimal. 12 divided by 10 gives me a decimal. I will get 12 divided by 6 and 2. But 6 isn't prime, so I repeat this, and I will get 6, 2, and 3. Well, 2 and 3 are prime. So 12 as prime factors are 2 times 2 times 3. And that's how we build factor trees. The same thing can happen for variables, but it's a little bit easier to see with a variable. Now, the variable x squared is made up of x times x. And so our factor trees for variables are relatively quick to make. And for individual terms, 9xy squared is made up of 9xy times y. And so we can factor things out by breaking it down by the numbers or variables that multiply to make up the larger term. What we want to find is this thing that sometimes gets called the GCF, or the greatest common factor. So by greatest, we're looking for the biggest number or the largest quantity. Common means shared. It's going to be shared across terms or shared with numbers. And factor. Factor is a part of multiplication. So a GCF, if we go back and look at 9 and 12, 9 was 3 times 3, and 12 was 2 times 6, which was 2 times 3. So we've got a factor tree for 12 that looks like this. Well, what is common to both of these? Now I've got A3 here and A3 here. So the GCF for 9 and 12 is 3. There's a greatest common factor. Let's look at 3 numbers. Numbers we're going to look at are 10, 25 and 150. So I'll take 10 on my calculator, and I'll divide it by, I'll work my way up. So 10 divides into 1 evenly, but 1 doesn't matter, right? 10 divides into 2 evenly to 2 and 5. Well, both of these numbers are prime. Those are my prime factors. 10. I take 25. I get prime factors of 5 and 5. When I take 150, what does 150 come into? Well, I know 10 and 15. And 10 is 2 and 5. And 15 is 3 and 5. Well, that I get from playing with it a lot. But as you work with different numbers, you'll find numbers that divide out. And as long as you keep dividing down until you don't get integers anymore, you'll get a nice factor tree that you can then compare. Well, looking for things that are common, this has a 5, this has a 5, this has a 5. And so the GCF of these three numbers is 5. If I look at x squared and x cubed, x squared is made up of x times x, and x cubed is made up of x times x times x. So looking for the greatest common factor in these, this has an x, this has an x, this has an x, this has an x. So in common, they both have a GCF, a common factor of x squared. Combining this, we can get 12a cubed as a term and 18a squared. My variable, if we look back here, here's a pattern that we're going to see with variables, is the greatest common factor is the lowest exponent. I know that's confusing. The greatest common factor is the lowest exponent. But here we can look. This has a squared. You can't get an a cubed without having an a squared in it in the first place. And this already has a squared. So we know our GCF is going to have an a squared. So we've taken care of the variable. And the variable is usually the easier part to get out of greatest common factors. And now we need to look at the numbers. 2 times 6, 2 times 3. Well, 18 is 3 times 6, 2 times 3. It has a 2 and a 3, and a 2 and a 3. So they both share 2 times 3, 2 times 3 is 6. And so the greatest common factor of 12a cubed and 18a squared is 6a squared. And this is what we do with greatest common factors. And we'll find as we go to factor polynomials, greatest common factor is a thing that we'll want to pull out of terms. We'll want to pull it out front in terms and reverse distribute. And so looking for GCF is important.